Yes, examples? Derivative of e functions, especially the special exponential function with base e. So let's get into the playlist. E to the power of x, right? I'll do it like this. Here it's always f of x, and here the derivative e to the power of x. Also here, if anyone wants to go deeper, wants to know what's special about it, why is the derivative of e to the power of x exactly e to the power of x again? I can only recommend it again and again. It's really fascinating to understand that you have a power here, base raised to the exponent, and e stands for Euler's number. Where does it come from? Why is it like that? The rest should actually be totally relaxed. If you multiplied a number, then a constant factor, it stays 2 times e to the x, right? If it was 10 times e to the x, the derivative would also be 10 times e to the x. If something is added to e to the x, like some people say, plus 10x squared, for example, then please look, you have the part with the special base e. Yeah, e to the x, when derived, that's e to the x. And here are the basics that you already know from polynomial functions, namely 10x. 10x squared derived would be plus 20 times x. So, and you just need to watch out for that. Then comes the first important step in understanding. What happens if we have e raised to, for example, x squared in the exponent? Then you have a composition. And here too, I can only recommend reviewing the composition of functions again instead of just memorizing it. Basically, it's again e to the x squared, right? X squared. So the part with e. That stays the same, but I also multiply by, you might ask, where does the 2x come from? That's the derivative of the exponent, which in this case is the derivative of the inner function, namely x squared. Now you can combine again, right? You have a number times the e part again, in this case x times x squared, and the constant factor 10 stays the same. E to the power of x squared also stays, but it's still multiplied by the derivative of the exponent. That would be 10 times 2, which is 20, so 20x times e to the power of x squared. And now again here, I always say, once you've recognized the structure, the danger is gone. 10e to the power of x squared, and now, for example, I do minus 20x. Yes, that would be the derivative of that part. We've already clarified that. It would be 20xe to the power of x squared. And now there's still minus 20.